Hello guys, we're going to do a quick lesson on variables on both sides. So this is an equation where you have an expression on both sides of the equal sign. So our first problem is going to be a word problem. Trip and Nancy are competing against one another in their handyman business. Trip charges a one-time fee of $10 plus $8 per hour. Nancy, however, charges nothing up front, but she does charge $9.25 per hour. How many hours would it be where they both work, or I should say, both would charge for the same amount of work? So, for example, if they both work 1 hour, it'd be $10 plus $8 times 1, it'd be 18 bucks. So Trip would charge them $18 for 1 hour of work, whereas Nancy would charge just $9.25 for that hour because she doesn't charge anything up front. All right, so what you want to do is you want to take Trip's rate and Nancy's rate and set them equal to each other. So $10 plus $8 per hour. Now for $8 per hour, you can do 8 times H. H could represent hours. And then for Nancy, it's going to be $9.25. It's going to be over here. So it's going to be $9.25 times H, because H represents hours. Multiply that by how many hours she's going to work. So for this situation here, what you want to do is you want to have variables on one side of the equation, not on both. But it starts out with both sides of the equation. Okay, so you want to either get rid of this one or get rid of this one. My recommendation is get rid of this one, so that way all you would have left is 10. And then you'd be able to figure out what H is. So what we're going to do is we're going to subtract 8H from both sides. This is going to cancel out because the opposite of adding 8H is subtracting 8H. So what you have left is you have 10 on this left side here, and then here you have 9.25 minus 8 is going to be 1.25, and then you're going to bring down the H with it. So basically what it's saying is this. So Nancy's charging $1.25 per hour more than Trip is, right? But Trip is charging $10 more up front. So that's the difference between the two. But basically what we're doing is we're trying to set them equal to each other. So we're trying to find out how many hours would Nancy have to work in order to get to that $10 extra that Trip would have charged extra. That's basically what's happening here. All right, so anyways, so we're going to do the opposite of multiplying by 1.25, because that's what this means. This is a multiplication problem. So the opposite is dividing by 1.25. So we're going to divide both sides by $1.25. And so H is going to equal to 8. So it's going to be 8 hours. So they both work 8 hours. They both would charge the same amount of money. All right? If you plug that back in here, 8 times 8, 64, plus 10 is $74. And then 8 times 9.25 would also be $74. So for any job that requires it, they're both the same. If they both have the same amount of, work ethic, if they do a great job, both of them, there's no difference between the quality of their work. Trip would probably be more expensive in the short run, but in the long run, he would end up being cheaper. Nancy would be cheaper in the short run, all the way up to 8 hours, but anything after 8 hours, she would end up being more expensive. So, anyways, so that's the example there. That's just a word problem example. All right, let's do number 2. We've got basically a couple more problems. We've got 5 more problems, and these are going to be variables on both sides, just these 2 here. And then we'll do another set with variables on both sides, but with distributive property. All right, so you can't combine these 2, and you can't combine these 2, right? So what we have to do at this point is we have to get rid of one of the x's. So either we get rid of the 3x or we get rid of the 6x. My recommendation is get rid of one of them. I would probably get rid of the smaller one. So that would be what I would do. So you subtract 3x from both sides. And again, it doesn't matter. You could actually subtract 6x from both sides. but it would end up being over here. This would cancel out, and then you'd have x over here, which is fine. All right, so this is going to cancel out. All you have left over on the left-hand side is 5. Actually, minus 5 or negative 5 equals 6x minus 3x is 3x. Bring down your plus 13. So basically, all this is a one-step equation. Okay, it's just a little bit backwards, but that's basically what it is. So now, our goal is to go from this down to x equals what we're looking for, our solution to x, right? So you're going to do the opposite, the inverse operation of adding 13, which is subtracting 13. So if I subtract 13 from this side of the equation, I also have to subtract 13 from the other side of the equation. You're going to end up with negative 18 equals 3x. And then last but not least, you have to deal with the 3. We don't want to get rid of the whole 3x. We want to subtract 3x from both sides. That's not going to solve anything. It's just going to put it over here, basically. What we want to do is we want to get rid of the 3, right? But the only way to get rid of the 3 is divide it by 3. So 3 times x, if you divide that by 3, that'll cancel out. All you have left is x. But whatever I do to one side, I'll also have to do to the other side. So that's going to end up being a negative 6. Now you can check this. You can plug it back in here, right? So if we plug that back in, let me try to do that real quick. So 3 times negative 6 minus 5 equals 6 times negative 6, right? You see I'm plugging them back in both places, plus 13. When you do that, you see this is negative 18 minus 5. This is negative 36 plus 13. When you actually combine those two together, you get negative 23 here, and you get negative 23 here. So they both equal each other because they both had the same solution, right? X had the same value. So you're able to have them equal to each other. So that's that. That's number 2. Number 3, same thing. You want to get rid of one of the x's. Either we get rid of the minus 5x here or the negative 3x here. Doesn't matter. My recommendation, I always get rid of the smaller one, so to speak. Technically, this is the smaller one because the bigger the negative number, the smaller it is. But anyways, we're going to get rid of the 3x. So I'm going to add 3x to both sides. This is going to cancel out. So negative 5x plus 3x is going to be 2x, negative 2x, or minus 2x, equals 11. And now this is our two-step equation. Now we're going to get rid of the 9 on both sides. Bring down the minus 2x from the negative 2x equals 11 minus 9 is 2. Then we're going to get rid of that coefficient, that negative 2. So in order to get rid of that, to separate that from the x, we have to divide it by itself. So we divide it by negative 2. This will cancel out. And then we divide this by negative 2 to get our answer. So x equals negative 1. And you can plug it back in, see if it works. 9 minus 5 times negative 1 equals negative 3 times negative 1 plus 11. So negative 5 times negative 1 is positive 5. 9 plus 5 is 14. Negative 3 times negative 1 is positive 3. Positive 3 plus 11 is 14. So they both equal each other, so it's good. So that's going to be our solution right there, negative 1. Okay. Sorry if I'm going a little too fast. I try to keep this under 10 minutes as best I can, but it looks like it's not going to be quite under 10 minutes. But we'll try to keep a steady pace here. All right. So this one here, same exact thing as 1, 2, and 3, except the difference is this is in distributive property. So you can't subtract x minus 5. They're not like terms. There's nothing you can do here. Nothing you can do here. However, we could distribute the 3, and we could distribute the 6. So distributing the 3, what that means is you're multiplying 3 times x, and then 3 times 5. 6 times x, and then 6 times 3. So you're going to get 3 times x is going to be 3x. 3 times 5 is 15, but you keep that sign there. 6 times x is 6x. 6 times 3 is 18, but you keep the sign there. Right? Or another way of thinking about it is A positive times a negative is a negative. Positive times a positive is a positive. Okay? All right, so now we got variables on both sides. We're going to solve it like we did for 1, 2, and 3. Let's get rid of the 3x. So the opposite of positive 3x is minus 3x, or negative 3x. That's going to cancel each other out. That's the goal, right, to get rid of this. But whatever I do to one side, I also have to do to the other side. So we got minus 15, or negative 15, if you will, 3x plus 18. Now you got a two-step equation, and let's solve for x. So we're going to subtract 18 from both sides. You got negative 33 equals 3x. Then you divide both sides by 3. And then x equals negative 11. And you can also plug it back in and see if it works. It works. All right, so let's do the same thing here. 5 times x, 5 times 2. Just distribute the 5. 5 times x is 5x. 5 times 2 is 10. Right? It's positive, so we just leave it like that. Subtract 3 equals x plus 11. Now, before we consolidate our x's, before we get rid of one of the x's, we can't combine those two, okay? We couldn't before because this was in parentheses, but now we can. 10 minus 3 is 7. So you got 5x now plus 7, because it's positive 7, equals x plus 11. Now we can solve it like we did number 4. Let's get rid of the x's. I'm going to get rid of this one because this is smaller. So x minus x is 0. 5x minus x is going to be 4x. So 4x plus 7 equals 11. Now you got your two-step equation. So again, we're going to get rid of the 7, we're going to get rid of the 4, but let's get rid of the 7 first. We're going to do the inverse operation, and we're also going backwards in the order of operation, because normally you would multiply and divide before you add and subtract. But we're not looking for the answer. We already had the answer. We're looking for part of the problem, x. So in an effort to do that, you have to go backwards in the order of operation. So adding 7, the opposite of adding 7 is subtracting 7. So we're going to subtract 7 from both sides. We've got 4x equals 4. Then divide both sides by 4. X equals 1. Okay? And that's that. And then one more. This one's a little bit bigger. This one's a little bit more difficult, if you will. Only because you have fractions. If you want to, you could, if the fractions are normal, okay, what I mean by normal is like 1/4, 1/2, 2/5, you know, so on and so on. But if you get a fraction that is going to repeat itself or have an irrational number of some kind, or something that might terminate but might have a lot of digits in it, you might want to just leave it as a fraction. But if you're one that does not like fractions at all, okay, and there's a few of you out there, and that's okay. You're going to just convert this over to a decimal. So instead of using 1/4, you could just use 0.25. Okay? And instead of using 3/4, you could just use 0.75. And if you're asking how do you get that, you just divide the top by the bottom. So 1 divided by 4 is 0.25. All right, so let's get started. So 0.25 times x and 0.25 times 4. 0.75 times 3, 3x I should say, and then 0.75 times 2. So 0.25 times x is going to be 0.25x, plus 0.25 times 4 is going to be 1. Subtract your 3. 0.75 times 3 is going to be 2.25x. 0.75 times 2 is going to be minus negative 1.5 or 1.50 minus 6. All right, now we can combine like terms. We're not going to get rid of the variables yet. We still can combine these two here, and we could combine these two here. So let's do that. So 0.25x, 1 minus 3 is going to be minus 2 or negative 2. Negative 150 minus 6, so if you subtract from negative, you get a bigger negative. So, but the 2.25x is going to stay the same, so it's just going to be minus 7.50 or 7.5. Now, so now we're back to what we were earlier in this lesson about variables on both sides. You got a variable here and you got a variable here. So we got to get rid of one of them. I would get rid of the smaller one. And then what you have left, you have that -2 or that -2. This will end up being 2x, and this will be 750. So this is a two-step equation. We're going to get rid of the 2. We're going to get rid of the -750 so we can find out what x is. So the opposite of -750 is adding 750. So you add 750 to both sides. This will end up being $5.50 equals 2x. And then you do the opposite of multiplying by 2, which is dividing by 2. And that's going to be x equals $2.75, I believe. Let me see. Let me double check. It's been a little while since I did this one. 2, 4, 1, 5, 7, 4, 1, 0, 5. Yeah, $2.75. Okay. So $2.75, if you will. All right, that's going to be x. I'm not checking that. That's going to take too long, but that's it. All right, hopefully that helps. I know some of this can get complicated. It can. Just take one step at a time, convert to a decimal, and then just go from here, rewrite the problem. Force yourself to rewrite the problem so you can get a clear direction about where you need to go, about what's left over and what needs to be dealt with. Okay? All right, hopefully that's it. That helps. Have a great day, guys, and I'll catch you in the next video. Bye.